Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be discussing the 2004 Calculus BC exam, question number 2. This is from the B version of the 2004 exam, and so it is a Taylor polynomial question that involves a graphing calculator, but actually it really only involves a graphing calculator for part D with Lagrange error bound. And actually, since this year we have not covered Lagrange error bound due to distance learning, I will be foregoing part D until a later time. So without part D, it's actually a pretty straightforward FRQ. The question reads, let f be a function having derivatives of all orders for all real numbers. The third degree Taylor polynomial for f about x equals 2 is given by that thing. In part A, we were being asked to find f of 2 and f double prime of 2. So pretty straightforward right now. F of 2 is like plugging into your Taylor polynomial. So what that does is it makes anything with an x minus 2 in it go away. So I'm hoping that f of 2 straight up being 7 is actually clear enough. If it's not, as always, comments and questions are always welcome in the comments area. So again, just to reiterate, I just plugged 2 in to my Taylor polynomial, making the terms with the x's become 0. So that pretty much canceled it out pretty quickly. If I'm going to find f double prime of 2, I better find f double prime of x. So, and if I'm going to find f double prime of x, I better find f single prime of x. Well, that's going to be negative 18 times x minus 2 minus 3 times, 9, and then x minus 2 squared. That's f prime, but remember, I'm trying to find f double prime. So that's going to be negative 18 minus 18 times x minus 2. That's my second derivative anywhere, but in this case, I'm going to take my second derivative at 2, making, once again, the x pieces go away, giving me simply negative 18. So pretty straightforward in part A right there. Part B asks, is there enough information given to determine whether f has a critical point at x equals 2? If not, explain why not. And if so, determine whether f of 2 is a relative min, relative max, or neither, and then justify your answer. Okay, well remember, critical numbers happen when the first derivative is equal to 0. So let's find out what f prime of 0 is. Well, luckily we found f prime up here in part A. And if I plug in 0, why am I saying 0? I'm saying 2. I apologize, 2. If I plug in a 2, I got a little ahead of myself there. If I plug in a 2, I get 0 for my first derivative. So, does that indicate that I have a critical point there? Yes, I do. I have a critical point, because critical points are defined as where the first derivative will either be 0 or undefined. So we definitely have a critical point there. And since our slope is 0 at 2, we actually can determine min, max, or any kind of relative extrema behavior. And so I can't do a sign chart on this thing, which means I'm resorted to doing what's called the second derivative test. Now the second derivative test says that if my function's derivative is equal to 0 at a point, and I can't sign test it, then I can evaluate the second derivative at that exact same spot. Well, we actually found out what that was in part A. That's negative 18. And because that's less than 0, that means that f is concave down at x equals 2. And since f is horizontal at x equals 2, horizontal simultaneously concave down, that means local maximum. So we can say by the second derivative test, f has a local max at x equals 2. So I hope that was clear. I do apologize for plugging in 0 in the beginning. I hope that didn't confuse you all. I got a little ahead of myself. F of 2 was 0, so I kind of jumped straight for the 0 there. My apologies. Okay. Part C, it says use t of x to find an approximation for f of 0. And then, is there enough information to determine whether f has a critical point at 0? Okay, well, we can do that. F of 0 is going to be 7 minus 9 times, when x goes to 0, all you get is a negative 2 squared minus 3, and then once again a negative 2 to the third. And actually, you can go and leave it like that if you wanted to, or again, on the AP exam, you don't have to simplify anything. If you decide to simplify, you'll end up getting a total of negative 5. Now from here, it's asking you if there's enough information to determine if there's a relative extrema or a critical number at x equals 0. Well, it's kind of an odd thing. These Taylor polynomials are interesting. In the problem up top here, they specified that this Taylor polynomial is about x equals 2. And because we don't know its radius of convergence, we can't actually assume that it's anything other than where we're at. We can only really assume that this Taylor polynomial is only accurate about x equals 2. Again, we haven't found any kind of radius of convergence or anything like that, so we can't make an assumption about how accurate this polynomial does, in fact, represent its particular function. At f of at 0, you could be way divergent from what your polynomial is meant to represent. So actually, the answer to this question here is no. There is not enough information. So all you do is you just say no. This Taylor polynomial is only accurate about x equals 2. Therefore, moving down. Therefore, there is no way to tell anything about relative extrema or critical points. So there's an interesting little tidbit about Taylor polynomials for you. And so I think that will cover it. Again, we're going to pass on Lagrange error bound because we haven't covered it in the class yet, and because the AP exam won't cover it, we can go and bypass that and then save it for a later date. I hope this clarifies this FRQ. I think it's pretty short and sweet. As always, please leave comments or questions in the question area, and I will see you in the next episode.